Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to focus on page 15 in the reference table, the characteristics of stars chart. Now this chart organizes our stars based on a couple different factors. One of the factors is going to be luminosity, how bright a star is or how much light a star is going to give off. That's going to be along our vertical axis. Our horizontal axis, there's two scales. Temperature in degrees Kelvin, that's going to increase from right to left across. So stars on the right hand side tend to be very cool, stars on the left hand side tend to be very hot. Now each temperature is going to correspond with a color. Your red stars tend to be very cool, your blue stars tend to be very hot. On the right hand side just gives you a little scale in terms of size. Small stars are going to be on the bottom, big stars are going to be on the top. Now many stars are going to be organized by mass and by size. That's where a lot of our stars are going to fall into those categories. So we have supergiants, which are an intermediate stage. They're kind of middle-aged stars. We have giants, okay, which again are middle-aged stars. We have white dwarfs, which are late-age or very old-age stars. And we have what are called main sequence stars. Okay, those are going to be the early-age stars. And that's actually where our sun is actually going to fit into that category as well. So one thing that happens quite a bit is comparing stars. So you need to understand surface temperature, color, and luminosity in regards to your stars in this chart. Let's show you how this is going to be used. So for instance, our sun has a temperature a little bit less than 6,000 degrees Kelvin, and our sun has a luminosity of 1. Okay? Luminosity of 1 is an arbitrary number given to our sun. Any numbers bigger than 1, such as 10 and 10,000 for instance, just tells you how many times brighter a star might be. So for instance, the number 10 represents 10 times brighter than our sun. 10,000 represents 10,000 times brighter than our sun. But you also have numbers less than 1, which represents how many times dimmer. So for instance, stars that have a luminosity of 0.01 are 1/100th as bright. They're significantly dimmer than our own sun. So if you take, for instance, Polaris. Polaris is going to have a luminosity of about 6,000 degrees Kelvin. That star is going to be about a yellow star, okay, and it's going to be somewhere in the neighborhood of about 5,000 times brighter than our own sun. You can get a star like Eridani B. Okay, Eridani B is going to have a surface temperature somewhere around 18,000 degrees Kelvin, but it's definitely going to be a blue star. Okay, but it's going to have a luminosity about 1/100th as bright as our sun. And a lot of times our brightness of stars is going to correspond with the actual sizes. The bigger stars tend to be brighter, the smaller stars tend to be a little bit dimmer. Okay, so very important to be able to identify, okay, your stars in relation to luminosity, surface temperature, and color. So that's pretty much about it for this chart. See you next time.